Hello friends, uh, today I'm here again with a new lecture, and in this lecture I will derive the equations of motion using calculus. Okay, last time we used differentiation in a numericals, and today we will use integration. Okay, so while deriving the equations you will definitely get an idea about integration. Okay, about some formulas of integration which will be very helpful to you. Okay, so let's begin. As we know, the equations of motion you have already studied. The equations of motion are there are three equations of motion, right? Okay, this time we will do four. So number one equation, what is the equation of motion for the first one? V is equals to u plus at, right? V equals to u plus at. Okay, this was the first equation of motion. There v is your final velocity. Then what is your u, initial velocity, right? So initial velocity, acceleration, then t is your time. Okay, now how you are going to do this? Okay, integration. So what we know, if a body starts with initial velocity u, then after time t it attains a velocity v, then the acceleration will be a. Okay. So yeah, we will take what is the acceleration. Okay, a is equals to dv by dt. We have known in the last class acceleration is your derivation of velocity on time. Okay, velocity is changing with respect to time. Velocity is time dependent, therefore it is derivation of acceleration. Any instantaneous acceleration is derivation of velocity with respect to time. Now what about in differentiation? We just calculated a small instant at any point. Okay, what about integration? Integration is just adding up of all such points and finding as a whole. Integration, summation of all the instantaneous points. Okay, so here now a into dt is equals to dv. Fine. So now here we will integrate it both sides. Integrating both sides. Integrating both sides. Instantaneous acceleration. Now this. So integrating both sides, what you get? We have a dt equal to dv. Now this sign is integration sign. Okay, so there must be some limits because these are definite. Okay, integration two types, indefinite and definite. In definite we have fixed limits, and in indefinite integrals we don't have any limits. So yeah, we started at initial velocity u and ended at final velocity v, and here at this point t was equal to 0, and at this point suppose time t is equal, time is equals to t. Now during this whole process your acceleration was a. Okay, so velocity changes from u to v. So here a is a constant term, so a will come ahead. So dt. Now what will be the limits of time? It will be from 0 to t. Okay, because the body starts with initial velocity u initial velocity u after time t attains velocity v. Okay, then instantaneous acceleration is given by a is equals to dv by dt. Okay, so that integrating both sides, so limits of time will be from 0 to t. What will be the, now here integrate, here what we will integrate time, and in this side what is our integration coefficient, that is dv. So here velocity will be integrated, and in this case on the left hand side time will be integrated. So velocity, it will be from initial was u, this final. Okay, so limits, this limit, so this is the limit, right? So suppose 0 to t, so this is the lower limit, this is the upper limit, means this is the initial, this was the initial condition and this is the final condition. This was the initial and this is the final condition. Okay, so now, so now a, this, it will be 0 to t now. So how you are going to integrate this? So integration of, suppose I take x into dx. Okay, so this x and I'll put here n. Now this is the integration coefficient, so here t is the integration coefficient. So integration of x and dn is x to the power n plus 1 by n plus 1. Okay, this is integration, plus a constant is there, since this is indefinite, here no limits are given, so here we add a constant. But in this case, since it is finite, it has got limits, so we don't need to add constant. Okay, okay, so this is the formula. Okay, but here we don't have anything, we have only, we don't have a t even, we have 1, right? Instead of t we have 1. So now what about integration of a constant term? Okay, integration of a constant term, here we don't have anything, we have 1. So integration of a constant term will be, here 1 means what, it means x to the power 0, we can put 1 equal to x to the power 0. So if I use this formula, then it will be x to the power 0 plus 1 by 0 plus 1, that means we get x. Okay, so in this case integration of dt, so what we get, we get t, and the limits we will just write it like this in the square brackets. The lower limit will be, we will place below, and upper limit will place above. Okay, same here dv, it was dv, right? Okay, so dv, so what will be dv, again same thing, here also 1, so integration of dv will be v, so here limits we will put v. Now after putting these limits, how to solve, right? Okay, so from this step I'll write here only, I won't go to the next page. So here I have a and these two limits, right? So while writing this, now after how to put these limits, use these limits, right? So first I will put the higher limit, the value of the higher, what is the value of the higher limit, it's t, so in place of t I'll put it t only. Then I will be there will be minus upper limit minus lower limit. What is the value of lower limit? It's 0, that means t is 0, t equals to 0, so I put it here like this. Now equals to, again, now v, what is the upper limit, that is in place of velocity I'll put v only, and what is the lower limit, u, in place of v I'll put now u, and in between them will be minus, that is upper limit minus lower limit, whatever it is. Okay. Hmm. So now t minus 0 is your t, so you get at, and what is the v minus u, you get a v minus u. Okay, if I bring this u on the left hand side, it will be u plus at is equals to v. Okay, so guys, I think you have understood. Okay, so here you were introduced with the formula of integration, this one, integration of constant term and integration of something n to the power n. Okay, this formula only we have used. This is one of the integration of x to the power n into dx. Now here only that thing will be integrated. Suppose here it is t to the power n, then here integral coefficient must be dt. If there is, suppose y to the power y anything y, then here should be y. Okay, you cannot integrate x dy. Your x will become your constant. Fine, I hope this is fine. And in your physics you will get integration with limits only. Okay, so I think the first formula we have derived. So v is equals to u plus at. This is the first equation of motion using calculus. We have derived this equation. Okay, now what about the second equation? Right, what is the second equation? Second equation was v square equals to u square plus twice as. Many of you remember like this. I think it's twice as v square minus u square. Okay, but I have remembered it like this only. Okay, so how to solve? Now see, here we need as. Okay, so we'll find something else. How? What will integrate? How to integrate? We need as here. So again we will use the same thing. So we'll assume a body starts with initial velocity u, and after time t, okay, and after time t it attains velocity v. So displacement, find the displacement. Okay, that is okay, find the relation between. So how you are going to find it out? So again we'll simply put a acceleration, what we know, instantaneous acceleration at any point. Same, body is moving with initial velocity, start with initial velocity u, final velocity v. Okay. So at time t is equal to 0. Now since here displacement is given, so we will consider displacement limit also. Okay, and time is not mentioned here. So in this you need to know before and only that here we will not integrate time, since time is not nowhere is time na, in this formula. In this formula time is not there, so we won't integrate time. Rather we will eliminate the value t and use something else. So t equal to 0 and this is t equal to t, and here okay, just at the start your displacement will be 0 and final will be displacement will be s. Okay, now a is equals to, what is your a? We know acceleration. Okay, after time t your acceleration, there will be change in velocity, so the body will be accelerated and the acceleration will be equals to dv by dt, as you know. Okay, now we don't need dt because we are not going to integrate t this time. We don't need it actually in the formula. So how to change it? Okay, what to do? But we need v. So in place of dv, what I can write? ds by dt. Okay, let's see. dv, in place of dv, okay, if it is ds by dt, it will be dt square. No. Mm, if I put here dv by ds into ds by dt, now see here. Okay, by doing this your dt will be gone. See, dv by ds, I have multiplied one ds because I need s in this formula. So displacement I require, displacement is required in this formula, so I have to introduce integral coefficient of displacement. So ds is introduced here. Now if I multiply, then it should also be divided, so there is no disturbance in the formula, or the balance remains same. Now a is equals to, just keep it like this, dv by ds, and What about ds by dt? You have known in your last lecture velocity is equals to displacement upon time. Okay, instantaneous velocity is a displacement upon time. So here you can put v now. Okay, now as you bring it this side, to integration ds, now v into dv. Okay, now integrating both sides, what to do? Integrating both sides, integrating both sides. Now, as you know, integration formula, what is the formula? So the first formula of integration, x to the power n into dx will be equal to x n plus 1 and divided by n plus 1, right? And what was your derivation? Your derivation was just opposite of this, na? ddx of x to the power n was n into x n minus 1, right? Okay, and into x n minus 1 and x n minus 1. So if you just see it like this, okay, this formula, from this formula only I'm going to here just put it like this, xn. Okay, now integration of xn minus 1, okay, equal to x n into n by x. So the other side, okay, leave it, leave this part. Okay, remember this formula, and integration of any constant term will be a that term only. X integration of dx will be x. So integration of x to the power n will be x n plus 1 by n plus 1 divided by. Okay, now what will be integration of ds? It will be as, okay, what will be the limits, you know, from 0 to s? So here will be 0, here will be s. Now here integration of v dv, now v to the power 1, so what will this time it will become, okay, what is integration of v to the power 1 into dv from this formula? Okay, use this formula. So it will be v power is 1, so 1 plus 1 will also 1 plus 1, so it becomes v square by 2. I hope you have understood, right? So it is your v square by 2, v square by 2. You got it? Now use the limits. What was the limits? Our limits was from, yes, u to v. It was u to v, u to v. It's u to v. Just a second, bro. Okay, guys. So yeah, v square by 2, and your limits will be from u to v. Now you know how to use the limits. Okay, so it's like, wait, previous page only, let me go to the previous page here. Okay, I can grab this, I can write here only. So here it is a upper limit minus lower limit. Here will be, now in this case, so what is the upper? V, it was v, so it is v square by 2 minus, what is the lower limit? U. In place of v, now you will put u, so it becomes u square by 2. So it will become as, now this is LCM 2, so it is v square minus u square. So v square minus u square will be your twice a s. So you see, your second equation of motion is also derived using integration, okay, using calculus. I hope this part is a tricky part, so you need to remember this part. See, in the last formula also we have started with acceleration, instantaneous acceleration. In this statement also, this equation of motion also, we have started with acceleration of motion. So these are the key points you need to remember. Okay, if you know where from where to start, then definitely you will end up with a result. Okay, so this is the start acceleration. Then you need to do some changes in this, because here time is not required and we require s. So you need to introduce the integral coefficient of displacement, that is ds. Okay, so how you are going to introduce this? You are going to multiply both and divide, so that the equation is not disturbed. Okay, so this is your second equation of motion. I hope it is clear to you. It was a bit simple. I think it is clear to you. Okay, then next, let us move to the next one. What is the next equation of motion? Our next equation of motion is as equals to ut plus half at square. Okay, you have learned this, as equals to ut plus half at square. See, we require so many things. We require u, we require a, we require s. Okay, so how to start? Just a minute, guys. Hello, guys. I'm back. Okay, so we were solving the third equation of motion, that is as equals to ut plus half at square. So how you are going to start this? Now, till now we have got two formulas, that is s equals to s is no, it's twice as is equals to v square minus u square. Again one we got v is equals to u plus at. Okay, so in these two equations we started with acceleration equals to dv by dt. Okay, we started with dv by dt. Here also we started dv by dt, and in this equation we have just made, we have introduced s. Okay, we in and remove this dt. So how we did dv by ds into ds by dt, this was, and ds by dt was your v. This was how we have done. In this case we just integrated it because we need v and t. Okay, so I hope you remembered this. Now for this, here again same thing, a body starts with initial velocity u, after time t it attains a final velocity v. Okay, same thing, your limits will be, t will be 0 to t. Again displacement will also be from 0 to s. Okay, velocity will change from v to u, u to v, sorry, u to v. Okay, now in this case you see here only initial velocity is given, your final velocity is not given. Here s and t is priority. This relation is also known as position time relation. Okay, I don't know how many of you know, it is known as position time relation, and this relation is known as your velocity displacement position velocity relation, and this one is your velocity time relation. Okay, they don't like this. Now so this relation is position time. So here position and time will be integrated. So if you remember the relation like this, then you will know what to integrate. Okay, since this is position time, so here we will integrate position and time, and this is position velocity. So here we have integrated velocity and displacement. Since this is velocity time relationship, so here you have integrated velocity and time. Okay. So here we know velocity is equals to, here we'll start with, see, in these two equations we have started with acceleration, but here this one will start with velocity. Okay, what is the velocity? It is ds by dt. Fine. Okay, so now your v will be v dt equals to ds. Okay, now you already have your position and time integral dt, so no need to do any changes. Now do you need v here? See the equation, you don't need v, right? You need u and a. So what you are going to do, you are just going to use your first formula. You are just going to replace v is equals to u plus at from v here. Use it. So in place of v, you are going to use u plus at. I'm just keeping it simple, not digging much. So u plus at. Okay, now one will be your u dt, same thing like differentiation, then this will be a t into dt equals to ds. Now integrating both sides, integrating both sides, I'll rub this. Okay, here you can write, we know v is equals to u plus 80. Put like this. Now okay, so now integrating both sides, now integrating both sides, we will be integrating u dt. Limits will be from 0 to t plus a t dt, again 0 to t. Okay, since time is changing from 0 to start to end. Okay, now as what displacement, its limit also will be from 0 to s. Now what will be the result, guys? U constant, integration of dt will give you t, and limit will be from 0 to t. Okay, plus a into, again this is integration of t dt. What t dt? Okay, x to the power, this time it is 1, right? So integration of x1 dx will be your x 1 plus 1 by 1 plus 1, so it is x square by 2. Now we know integration of x dx is x square by 2. We will just remember it. Suppose if it is integration of x cube dx, then what it will be? It will be x to the power 4 by 4. Got it? If it is the integration of x to the power 5 dx, it is just simply x to the power 6 by 6. Okay, I hope you have understood. So yeah, limits to acceleration will be constant a, and then t, it will become a, since it is integration of t dt na, so it will become t square by 2. It is t square by 2. Now what is the limits? Your limits will be from 0 to t, and this one will become integration of ds is s, okay, from the limit 0 to s. Okay, put the limits. Okay, so once t minus 0, so t will remain. Okay, plus again in this, yeah, put t, then 0, t minus 0 will be again same thing, so a into t square by 2 will remain equals to s. So you see your formula is, if I reverse it, just s is equals to ut plus half at square. So it is derived. Okay, so thank you students. I hope this lecture was helpful, and hope you got some idea about integration also. Okay, so in my next lecture again I'll come up with few more derivations. Okay, yes, thank you for being there, and please like and subscribe my channel and kindly share it. Thank you. Have a nice day.